Okay, part 3, graph analysis. Compare each pair of graphs in the sets below and answer the question about them in the table below. So we're going to start with data set 1, and I'll scroll down here and show you that. Data set 1, city A, city B. So we're going to compare the data for every month of the year for average high temperature for these two cities and use this information to interpret which of these is closer to the equator and how do we know it. So what would you be looking for to know it? Well, if you think about a place that's near the equator, maybe someplace like Florida, we all know that it's kind of warm there all year round. Yeah, there's a little bit of a winter change, a little bit less hot, but it's closer to the equator, so it has less variability. And that's why so many people from New York like to move there. Okay, and if you were to think of other places that are even more tropical, like maybe in the Central America or the Philippines, Indonesia, it's even more tropical year round. Okay, they almost don't have seasons at all. So you're looking for places that have very little or lower variability, where they're pretty mild all year long. So let's see which one of these is closest to the equator. So first of all, not only is there not going to be a lot of variability, but you're not going to see any cold winters, or you're not going to have most severe winter. So we have a temperature here that says 90 degrees. And up here we have a high temperature of 80. Okay, and then our low temperature here is in the 50s, and our low temperature here is in the 30s. So I think you probably already have an idea which one of these is closest to the equator because of which one is on average warmer. Okay, but there's another way to tell, and that is in the variability of the data. And it will turn out, if you were subtracting this temperature, about 35, maybe 34, from 80, you get about 50, and then here you'll get a variability that's only in the 30, a difference of only in the 30s, like 30-degree difference, 36 maybe. So this is both warmer and has less variability, even though it looks more variable. This is one of the problems with these graphs. This is very important. Be careful when you look at these graphs. I might say this looks like less variability because it seems flatter than this graph, but that's the way the graphs are just plotted. You must look at the axes and then do the subtraction. Subtract the lowest temperature of the year from the highest. That's the only way to really tell, because this computer system tries to maximize the area of the graph, and unfortunately it leads you to visually making an error. This is not less variability than this. It just looks like it. You have to do the subtraction. Okay, so that's how you figure this out. Warmer weather and less variability closer to the equator. Okay, and that's the way you do the rest of them. Some of them are more challenging, but that's what we're here for. Ask questions. All right.